I have ported from Patchwork to two functions from the original Repmus library. It's the feuillete. I don't know if this is the correct pronunciation. And the tempo interpolation. I have paid dispatch to talk about it. The feuillete is for calculate metric modulations. It's another story, very different from interval series. And it's based on the idea from Francois Nicolas paper. It's this article, Le Feuillete du Tempo. He creates this idea of kind of layers of tempos. And he divided in three layers: the impulses, the pulse, and the measures. So as an example, I selected this this bar here, which we have the impulse, 16 of, the pulse, and the measure. This is the value of the rhythmic figure. And then we have the tempo of each one of these. So if the tempo is 60, right? We have to multiply by 4 to take the impulse tempo, because we divided by 4. And the measure tempo is divided by 4 because it's 15. It's in 15 beats per minute, right? So each measure, there's its tempo. The speed of impulse tempo and the number of pulsations in a measure. Here we have 4, right? And this function will have all these inputs: pulse tempo, measure tempo. And the arguments can be a number, a list of numbers, a list with B and 2 numbers. For example, B 1 and 5, we have this. All numbers between 1 and 5. And if we use -1, that's the standard input, we have the open situation. So it's an open variable. So we'll calculate all possibilities with this constraint. One interesting thing about this, it was constructed using the constraint solver, the Screamer, that is a Lisp library, and that it's always pretty much the same thing that OMCS does. It's of course it's different, but it's the same types of calculation. You have a limited number of variables, and we'll calculate all possibilities. So here I have transcribed. Sorry, I have transcribed this to the function. For example, the impulse tempo, the pulse, the measure, the speed of impulse tempo, and the number of pulsations. And we have only one solution, that is this one, because it's very limited, you know. And we can change this. For example, if I want to more results, I can use, for example, between 1 and 6, right? And I will left the measure open. Now we have got a lot of different results for metric modulations. So this will test these variables, all numbers between 1 and 6, and we'll calculate the possibilities of metric modulations. Right? But it's too long. This result is too long, and I think it's we can limit it to get more precise results. Another example that I thought is if we use a list inside instead of between two numbers, for example, 2, 3, 4, and 5, and 6. Then we have metric modulations that uses these divisions: 6, 5, 4, 3, 2. Right? So this function, I think it's very interesting. It's possible to explore it more, changing the impulse tempo, the kind of written figure you want to use, measures, different measures. I think is it. Any questions about this? I don't know if I'm talking too much.
No, it was very clear. It was yeah, I understood. Yeah, what was going on, and it's yeah, it's really great work. It's interesting to sort of have this function brought back to life from patchworks.
Yeah, this is one of my research. It's about patchwork, and Karin Haddad has helped me a lot with this, with the source code. And the idea, let me see if I have the tutorial patches from Repmus. Yeah. I have to say that this code was not written by me. There is two tutorials, one for feuillete and another one for tempo interpolation. The feuillete is the trickiest one. The tempo interpolation, it's more easy to use. This tutorial I have just copied from Patchwork. And about Patchwork, I have actually found a way how to run on my computer, how to load Patchwork using an emulator. I think it's. So I'm emulating the old system, Mac OS 9, to load Patchwork, and I'm studying it. It's a very interesting thing for me. And then I decided to do this. It's I don't know. Was only a wish. I found this very interesting, and I have to say it was written by Gerard Assayag and Claude Malherbe. And that's it. That's the other function. It's for tempo interpolations. It's more easy because we have a begin, end, and the number of steps, and then it calculates interpolation with some tolerance and a percentage of tolerance to the end. In the end, so it's more easy. You select the initial tempo, the end, and it calculates all metric modulations. And I think it's it.